I'm going to create a macOS command line application to demonstrate some of the features of the Swift programming language, as well as how to debug Swift applications in Xcode. As with all of my projects, I'm going to have a GitHub repository to hold the project. And so the first thing I'm going to do is create that repository. So I'm logged into my GitHub account. I click New Repository. I am going to create a repository named Swift Example 1. And the description of it is a macOS command line application to demonstrate Swift language features and debugging in Xcode. It's going to be a public repository initialized with a README that contains a gitignore based on a base gitignore for Swift. And I'm not going to have a license for this. I'm going to create the repository. And once it's been created, I'm going to modify my gitignore. So I'm going to edit it. And then in the other section of the gitignore, I'm going to add that I want Git to ignore .dsstore files. And once I've added that, I can go down to the bottom of the page where the commit changes boxes are, and I could say added.dsstore to gitignore. I'm going to commit this directly to the master branch. So commit changes. And if I go back to my repository, I have a new repository with a README and a gitignore. And this is going to be the basis for my project on my desktop. So I'm going to clone this. And in order to clone it, I need the URL for the repository. So I've copied that. I go to the terminal. And I'm going to change to my documents directory, in which I have a projects directory. And I now have a iOS and a macOS directory for my iOS and macOS projects. So I'm going to change my directory to macOS. And I now want to put a copy of the repository in this directory. So I'm going to clone it. So I'm going to type git clone and the URL. And once I've done that, I now have a Swift Example 1 directory. And if I look in that directory, I have a README, I have a gitignore, and I have a git directory.git that is used to manage Git for this project. So I have what I need to create an Xcode project that will be managed on GitHub. So I'm going to launch Xcode and then click Create a new Xcode project. If the last project you created is an iOS application, when you launch Xcode and create a new project, you're probably looking at a page like this. If I want to create a macOS command line application, I select macOS and then command line tool, hit next. And the name of my project is going to be Swift Example 1. The organizational name and identifier are set to what I'm typically using. This would be like your name and then a reverse domain name. We're going to develop in the Swift programming language, so I'll hit next. And in my projects directory and documents, I have the macOS folder we were looking at, and then I have the directory Swift Example 1, which was resulting from my clone of my repository on GitHub. So I'm going to select that directory, and then I'm going to say Create Project there. And when I create a command line application, I will get a project that has a main.swift in it. And this main.swift right now says import foundation and then print hello world. And if I were to run this, rather than launching a simulator like we got for the iOS application, this bottom area that shows standard out will be displayed, and any prints that occur will be printed here. So this print hello world displays down here in the output. And by the way, I'm going to put this window down. If we look at our hide and disclose controls, I can make that bottom appear and disappear in Xcode by using this control with a bar at the bottom. So this is the right side, this is the left side, and this is the bottom. So the import foundation is giving access to basically a foundation library in our environment. This is where a number of the things that we're going to use in the language are located. There'll be more about imports later, but we're going to leave the import foundation there to begin with. And I'm going to delete the print hello world, and I'm going to declare my first variable. The variable I want to create is called name, and I'm going to set it equal to my name, which is Dale. So Swift lets us declare variables by beginning the line of code with the word var, then specifying the variable name, and then in this case we're initializing the variable to a value, in this case the string Dale. By writing this line of code this way, we are implicitly setting the type for the variable name to string. And I can determine that name is declared as type string by holding the option key down, which gives me a little question mark, and clicking on name. And when I do that, it pops up the declaration saying that the variable name is of type string. And the question is, how did Swift know that? Well, it knew that because it's being initialized to a string. If I were to say on another line, have a variable age and set it equal to 24. 24 is an int, and so if I use my option key to get my question mark and click on age, we see that age is being implicitly set to an int. The var means it's a variable, which means that this thing can vary. So if I wanted to take the name and change it from Dale to Josh, it's okay with doing that. If I wanted to set the age to 25, then we're okay with doing that. Var for variable. Now if I wanted these to be constants, that is to have some value and then that value cannot change, I could use the word let instead, and the keyword let. And if I do this, then we're going to get a red exclamation point, and then it kind of decides, oh, well, yeah, there's something wrong here. Name can't be set equal to Josh. And if I click here, it says cannot assign to value. Name is a let constant. To fix it, let's change let to var to make it mutable. Mutable means changeable. So if I click here, it changed the thing that was a let back to a var so that I'm able to change the name to Josh. Same thing here with age. If I type let and give it a little bit to figure out that something isn't right, we see we end up with this red circle by age. We click on it, it says cannot assign to value age to value. Age is a let constant, and to fix it we would need age to be a variable. I'm going to delete those two lines for a moment. The variable name is a string because it's being initialized to a string. I can also specify after the name the type of the variable by putting a colon followed by the type. So I've not changed the type. The name was a string and it continues to be a string. It's just that I'm explicitly saying that name is a string here, rather than relying on it being implicitly set to a string through assigning Dale to it or assigning the string. So I can do the same thing for age. Age is an integer, and I can explicitly specify that the variable age is an integer. Now again, 24 is an int, so without int there, age is still an int. Now why might I need to specify the type even if I'm initializing it to a value? Well, let's pick another variable and let's call it value. And I set that value equal to 154321. Now value, because it's set to that number 154,321, is going to be an int. And I'm going to hold my option key down and click on value, and we see that it is an int. What though if I wanted value to be a double? Can I take 154,321 and assign it to value of type double? And the answer is, why, yes, I can. Value is now a double. Alone, 154,321 is not a double. It is an int. But if I specify that value is a double, then this thing can be assigned to it because it can take this int and assign it to the double because it's not losing anything in the process. Also, if I didn't have an initial value to set, then I would have to declare the variable as having a type, and setting the variable to a type but not initializing it means that we ultimately will have to talk about something called an optional, and we're going to put that off until a later session. So right now, all of the variables or constants we create, we're going to initialize them to having some initial value. So I have here name, age, and a thing called value. What if I wanted to print this information? I could say print name, and it would do just that. It would print the name. So if I run this application, we see down here in the output box that Dale got printed. What if I wanted to say something like name is Dale? The way that I could do this is I could print in a double quoted string, name is, but now I've got to actually print the name itself. And I have a couple of ways that I could do this. One is interpolating the value into a string, and we can do that using slash parentheses in the string and then putting the variable inside of it. So what we are saying here is name is, and then we want to take whatever name is and insert it into this string as a string. Well, name is already a string, but that still will allow it to be placed here in the string as a string. So if I run this, we have here name is Dale. What if I wanted to say something like whatever the name of the person is, their age is this. So I'm going to have a double quoted string, and I'm going to say name is age years old. So the slash parentheses name is going to be converted to the string that is name, so Dale will appear here. Age is an integer, it's not a string, but by putting slash parentheses around age, we're able to take the integer value and convert it to a string. So when I run this, it should say Dale is 24 years old. So I'm going to run this, and it indeed displays down here Dale is 24 years old. let's say I want to create a for loop and I want to count from 1 to 5, where 1 and 5 are included. And this is what it would look like in Swift. For I in 1, 2, 5. Open curly brace, close curly brace. So that will create a variable I, which is going to be an int, and it will produce values from 1 to 5 inclusive. And if I want to print out those values of I could say print I, and then I would, when I run this, first of all have Dale is 24 years old, but then it would after that display 1, 2, 3, 4, 5. Let's say we wanted to say I equal whatever I is equal to. So in a double quoted string, I could say I equals / parentheses and then put I inside of it. And if I run this, then we'll have I equal 1, I equal 2, I equal 3, I equal 4, I equal 5. So let's say, given the code we have right now, we want to commit this. I'm going to go up to source control, go to commit, and I'm going to say created several variables, printed values, and wrote for loop. And if I want to, at the same time I'm committing this, push this to the GitHub repository on the master branch, I can check this box and it will commit. So we're in the process of committing, and once it's done committing, it will push. I'm needing to enter my credentials for the repository, so I'm going to put them in. And it finished pushing. So if I go to GitHub on the web and I select this repository, we see Swift example 1 is there. If I go inside Swift example 1 and I go to main Swift, there in fact is the same code that I have over in Xcode, but now up in my GitHub repository. This is the basis of what you need to take the code that you see in the book and create examples so that you understand how the code works. It's also the basis for the next challenge that you have to work on, which is the Swift Language Basics challenge. What you're expected to do is create a repository, create an Xcode project, and then follow a set of requirements on declaring variables and writing some Swift code to use those variables. And it'll include variables and constants. Remember that var is used to create a variable and let is used to create a constant. Remember that when you are done writing your code, that you commit it and you push it to GitHub, and then you're going to submit the repository clone URL on Canvas.